that magnet here is the illustrate the real magnet that I use. It's called the ring magnet. That means that it's the pair of the pole is opposite to each other in just one circle. Then why I choose three pairs instead of 5 or 7 pairs is because in one rotation I know that the more pair pole up here, then the accuracy will increase. But in the market only available this type of the market, then and I think that the accuracy is one rotation is create 3 per. I think that enough for the method. For this type method is 3 per rotation is enough.
Why enough? You can claim something to explain this enough. What is your thesis?
So this tree is okay, you can apply whatever. It's not you have like here in the slide you say that the resonance is type A. So what is the specification of type A and how can you get this sacrifice is required to the calculation and so on. So this is more easy. It's one thing and you compare with different thing and you say, okay, this is the standard. So if you don't satisfy, how can you change? How can you adjust? This, I think this is more important. Everything is good, but we want to know how. Before I done the real electrical. I have read the reference. That refer the standard, the survey standard, and some of the international standard that I have tried in the thesis before, but not in the slide. No, I mean that you have the standard slide. And now you have to design a system and satisfy this kind of delivery. And in your system, there's some component, something you have to choose. Then you have the calculation in order to satisfy the requirement. For example, y is the people, y is 4 or 5 or 7. Okay? Then you choose. That's the way. Now you choose and you try. Satisfied, then you release it. It's not satisfied, and then you throw away. It's not the way. I mean that way. You have to have some calculation in order to satisfy. I can design. About the recognition method, it's the recognition. The recognition here, even if I increase the pair pole, it's not increase the accuracy very much because this is the water method. It means that if it's not do this task, then it will be compensated another task because when the recognition rotates, when the recognition rotates, then if it only rotates half of the rotation, then when you turn the turn on the flow rotation, then it will continue the rotation. Then it compensates.
But this depends on the resolution. Resolution of the display. If you want more precise, the resolution of the indicator is more precise. Then this one is totally not if you really want the exact.
The exact.
Yes. And I also have comment like it also depends on the pole sensor. It is possible for pole sensor to recognize the difference of the pole when you increase the number of poles.
You mean that when the flow goes through too fast, then the frequency needs to go very fast. Okay. About the pole sensor, this all depends on the pole sensor timing to capture the signal and the microcontroller to capture that signal. Right? The speed of the pole sensor is very fast. According to the data sheet, the pole sensor is only few microseconds to capture one signal, and the microcontroller also the same. So it takes a few microcontroller, then the rotation of the magnet, I think that cannot reach the limit.
You think that you must use that
No.
calculate
No.
it's very important. Because if you refuse design, so you can get anything.
The maximum rating of this meter is only 3 cubic meter per hour. The Qmax is only 3 cubic meter per hour. So it's really small.
It's not how the design you can increase your play because then you can get more exact. If rotate is very fast, so you can increase your play because it's very
You need a battery in your design. So how long you have to replace the battery for your battery?
You mean the battery 3 volt or the?
Yes.
The battery, the battery 3 volt, according to the calculation, is last for 1 year because the RTC block only needs the battery when for remain the oscillation inside the chip. So according to the data sheet of the CS 11307, it only take a few nanoampere to remain the oscillation.
Okay, so how to protect the data at the time you replace the battery? No.
Khó. Thầy bảo là khi nào thay pin mất thời gian làm mất để vào pin về lại sao?
Design is not good enough.
Gửi lại, nó đi ra thế mà.
When we replace the battery, so it's not because the computer will automatically update the time for the meter. It's depend on reset. It depends on reset of 1 minute or 2 minutes. It's the computer will automatically update the time for the whole meter. So even if in one moment the RTC is not correct, but after 1 minute or 2 minutes, data RDC. Inside the RS for any financial, they are S, Y, S small y. It's one of the weakness of that device. It cannot recognize the reverse and the forward flow. There are one solution is that we can put four sensor I talked about that. We put four sensor opposite to each other, then we can get rid of that problem. But it's a bit too complicated to manipulate. In the file, we put the one that is
straight line seems to be past 0. That's what 0.3.
Because in at the beginning, this you can see this number is the error of because during the test I start the test method when I see the line of the standard method go through the exact point. So that number not go through 0, 0. In the ideal case, it has to go to 0, 0. But in my case, it's a bit not the ideal case. But this number is really small compared to 1,000, 2,000. So it's not affect much to the calculation.
Do you have any sample for
I think that error is depend on each time I do the experiment, because I recognize the standard method not by the machine but by my eyes. So there are always the error. That error always exists. We just can manipulate this.
you're the one that what is the source of this error?
This source. In my experiment, this one comes from the accumulate of the whole point here, because this line is drawn by using this square method. It means that it's accumulate of all the point here. If this point just move a bit, then it makes this line become more error.
understand how the method this way method. Because when I see the table in the slide 9, yeah. So this is the all the values you get for every of the lines. Okay? And then you use the list square method to obtain the current value. But when I see more detail about this table, I understand. So because you know from the 10 meter, you have a number of rotation about like this, and you have a 100 meter. You have a quick difference. So from this point to this point, you have 10 times. Okay? Difference 10 times different. But the number of rotation is not really like this. So normally here, so the 2,960, but here you obtain only the 2,950. So it's a big difference. So I don't understand how you can get the parameter K with the next.
You see that the first data here, the small point here, and here is the separate data, not the continuous data. So
But it's not the trace line.
yeah. This one is in fact not a straight line. This one is represent for the table, and from that I use the list square method to divide the. This one is a straight line, but this point here is not on the straight line. This one is a straight line.
So it's not correct.
I think that the list square method is using by when we collect a lot of data, then we put the
in different point the same point.
in the different form.
Yeah, so all comes. But here you can create only one. Okay. That's all. Why you can too many value here. Because it's only one line here. You can place only one. And you can take only one space. So in your table,
Now play here is only for easy to represent. This one simply by this one divided by this one. This one by this one divided by this one. Not equation. I think that the list square method is we drive the linear line that go.
Okay, I have one more question about this section. So how we can get this point, for example? Because in the previous, you have the previous page. So you have the 3 values.
Yes.
For 10 meter. You have the 3 values for the 10 meter. And it's different. Yes, they are different. And for the next one, how you can draw this one?
This I will not find out the way to combine the whole data together. Just
So what is the list square method? How you can use the list square method? What is công thức như nào để ra được? What is the calculation? What is the equation?
The equation of this square method is that we want to try the square up, or we want to try the line. Then we calculate the distance from this point to the line. The real one to the line, and that we have to minimize that. We sum up all the.
Yeah. So normally.
Because you have only one line, then you have only one coefficient is span of this line.
So normally this square method is a statistical method. So where you use a statistical method, you need enough integrator. So for this line, you use only one value for the first column of your table. So it's not. And I'm sure that if you use all the parameters of the three columns or more, you will get another line.
Maybe I have to draw the three.
I think you have to combine all the and you have to
Tăng cái số lượng nó lên và đối với nó thì nặng của cái việc mà tích tầm 10 tích
You know, it needs to collect a lot of data and use all of the data you have in order to
Thế là phương pháp thống kê thì bao giờ thì em phải sử dụng rất là nhiều dữ liệu. Đấy. Thế thì cái đồ thị em vẽ đây là em chỉ vẽ cái cột thứ nhất thôi, thì rất là ít rồi. Và em có dùng cả 3 cột thì nó vẫn là thế nhưng về nguyên tắc là thường nó hỏi sẽ là em có áp dụng cái phương pháp này không. Còn nếu mà phương pháp này em chỉ vẽ cho một cột thôi thì như vậy là như thế là em chưa hiểu về phương pháp thống kê. Thống kê em dùng rất là nhiều dữ liệu. 3 cột là cái là chưa hiểu, nhưng mà ít nhất rằng là em có 3 cột dữ liệu thì em phải dùng cả 3 cột đấy để vẽ. Đấy. Em hiểu không?
Cái bộ đặc điểm này lại có một cái hệ số. Tất cả cái bộ số này đo này em mới có chỉ có một đường. Và trong cái đó em ở đây lại có một loạt các hệ số này.
Đây là
cô có hiểu
thực ra là cái cột này là cái cột để cho mình dễ nhìn thôi. Chứ thực ra là cái số liệu em nạp vào là